Now, we've looked at the steady state tuning process and how we can apply that on a turbocharged engine. However, we do need to be a little bit sensible about how we apply steady state tuning and what we're hoping to achieve. If we've got an engine that runs a relatively low boost pressure on the wastegate spring setting, like our turbocharged Toyota 86 that we're using for these examples. In that case, there's no reason not to tune all the way through to wide open throttle to our minimum wastegate spring pressure level in steady state. And there's a very good chance that we're going to use all of that range of the engine's operation quite regularly when we're actually driving it. This is going to give us the most accurate results in terms of air fuel ratio and ignition timing when we're off the dyno and we're actually driving the car. If on the other hand though, we've got an engine that is equipped with a very high boost pressure for its wastegate spring pressure, let's say for example that the minimum boost pressure that we can achieve is somewhere in the region of perhaps 20 or 22 psi, somewhere around about 240 to 250 kPa, then we may want to adapt our tuning procedure in steady state slightly. The reason for this is it's unlikely, first of all, that we're going to use all of that range of operation in normal driving situations. Let's have a look at our AFR target map, and I've drawn in here a red line representing the likely sort of boost curve we'd expect to see relative to engine RPM. Now in this sort of engine we're likely to still be using the vacuum area for our cruise operation, and we're also going to move up into positive boost pressure as we've already seen during normal cruise operation. However, we're going to find that particularly at higher RPM, in this case let's look at 4000 RPM, where the engine is capable of making almost its full 22 psi of boost pressure, we're going to find that this area here at the higher range of the boost pressure the engine can achieve, which we're very unlikely to be able to operate in under steady state operation. And the reason for this is that as we open the throttle further and the engine makes more power and torque, what happens is the engine also produces more exhaust gas energy, which helps spool and drive the turbo faster. So what we find is that there is a certain point whereby when we're actually driving the car, we'll find that the engine will tend to transition very quickly through this particular area here at higher RPM and higher boost pressure. We're not going to be able to sit steady state in this sort of operating area. In this instance, I would normally concentrate on my steady state tuning up to around about 200 kPa or 1 bar of positive boost pressure. So I would be focusing my energy in this region that I'm just drawing here. So again, we're moving up to around about 4500 RPM or 2/3 of our engine rev limiter, but we're not going to be worrying about the very high boost areas down at these RPMs, sort of 4,500 RPM. So we're going to be focusing our steady state tuning process up to around about 200 kPa. Now that leaves us with an untuned area, and how do we approach that? Well, the next step with these sorts of engines is to transition straight into doing wide open throttle ramp runs. Now that sounds on the face of it a little bit scary, because obviously we don't have an idea or a shape to our fuel and ignition tables at wide open throttle at these higher RPM areas, in this case from what I've drawn from probably about 3,500 RPM and above. So the process is to build up very slowly with our ramp runs. So we would start by moving through the areas we have tuned in steady state up to around about 3000 RPM, and we can see that we've tuned in steady state there, so we know just like our normal procedure that our fuel and ignition timing will be correct. Then we can start moving through into the untuned areas very slowly and building up a picture of our fuel and ignition timing as we go. Now once we've got the engine running all the way through under wide open throttle conditions, we can start to look at this area that we've missed here. So we can look at our sort of higher boost area between 3000 and 4500 RPM, and we can address these areas. Now, while the engine's only going to transition through these areas very briefly, very quickly, we don't need to be quite as precise with the fuel and ignition timing in these areas. We still can't obviously ignore them. So the procedure for tuning these areas is to simply interpolate the values that we've found under wide open throttle down to the area that we've tuned in steady state. So in this case, I've suggested around about 200 kPa. We can also use the interpolation function to help us fill out the volumetric efficiency or ignition table values in areas that we haven't tuned. Now, while I recommended that when we start increasing our boost pressure, we do so in 20 kPa increments, and this would allow us to completely fill and accurately tune both our fuel and ignition tables. There's no strict requirement that you must do this. Particularly when you're a little bit more confident with your tuning, we may choose to jump ahead slightly and perhaps jump in 40 kPa increments of boost. So in this case, let's have a look at our volumetric efficiency table, and let's say that we had accurately tuned our fuel at 140 kPa and our next increment was 180 kPa. Now, this leaves us with a zone at 160 kPa that we haven't accessed and we haven't tuned. So in this case, what we can do is highlight between those cells, between the cells we have tuned, and using the interpolate function, which is the I key here, what will happen is we just simply fill the 160 kPa zone with the value halfway between the two sites we have tuned. Now, this might not be absolutely perfect, but it's going to be very, very close, and it's a quick way of helping fill in our fuel and ignition tables in areas that we haven't tuned. So by this point, hopefully you've got a better idea of the way we can approach our tuning with a turbocharged engine. Again, I want to reiterate that really the way the engine responds to both fuel and ignition timing is no different to a naturally aspirated engine. The only real considerations we need to make are for controlling the heat that the engine is producing, and obviously we want to limit the amount of stress that we are placing on the engine where possible. If you do have any further questions, please ask them in the form below, and I'll be happy to answer them in the forum.